Hello everyone, welcome to my video series called Six Sigma in Action, where we cover real life case studies of Six Sigma using Minitab. In today's video, we will be looking at binary logistical regression, chapter 5. In this case study, binary logistical regression was used to collect all the customer survey data and create a predictive model that guided them as to which factors were most influential in increasing the probability of customer satisfaction. Since customer satisfaction has binary outcomes, either you're satisfied or you're not, that is why we use binary logistical regression in this case study. So let's start with the define phase for this case study. Again, just like all the previous case studies, we will be following the demake process here, and it starts with define phase. Define phase is where we clarify the problem and come up with a problem statement. Well, turns out that the owners of this busy restaurant in downtown Boston didn't think their customer satisfaction was up to par and wishes to improve their customer satisfaction. So the restaurant manager is asked to collect customer satisfaction data and suggest feasible recommendations to the owners. So the objective is to improve the proportion of satisfied customers at the restaurant. And the factors that the independent factors that the restaurant manager wishes to consider as an influence to the customer satisfaction is variety of drinks on the menu, the number of waiters, and whether a free refill is provided. And as I had mentioned previously, customer satisfaction is a binary yes and no event. Hence, the restaurant manager will be using the binary logistical regression to predict the probability of satisfying a given customer. And here it shows the equation for binary logistical regression, where p is the probability, beta 0 is a constant, beta 1, beta 2, these are all coefficients of independent factors x1 and x2. And that's define phase. Next, we move on to the measure phase. In measure phase, random sample of customers are surveyed on different days with different level of the influential factors. And the customers are asked whether they were satisfied with the service or not. So here's the data. As you see, uh, all three factors such as variety of drinks, number of waiters, and free refill is changed, and then a sample set of 10 customers are taken, out of which when there were six variety of drinks and 20 waiters and a free refill was provided, 4 out of 10 customers were satisfied. And similarly, when the variety of drinks were 3 and number of waiters working were 10 and no free refill was provided, only 1 out of 10 customers were satisfied, and so on and so forth. So here's the data. So that essentially was our measure phase, where all this data was collected as for different levels of the factors. So after the measure phase, the next phase is analyze phase, the demake process. In this phase, we basically load the data and run the binary logistical regression. So the first step here is, like I said, we will be running the binary logistical regression with these three factors for which we have the data. And then we'll be looking at the p-values that it generates to see uh, if the coefficients are affecting the customer satisfaction, if the model has a good fit, and again, if these factors are influential in the customer satisfaction and how much. So here you can see I've already loaded the data. Uh, we had we have 10 data lines here, and for each of them there is a different variety of drinks, number of waiters, and uh, free refill yes or no, and then the total sample size for the number of customers that were surveyed and what is their satisfaction number is also here. So now, in order to run the binary logistical regression, you go to stats, you go to regression, and you go to binary logistical regression, and you see fit logist. that one. And then this is event and trial. Uh, the data is already loaded. Like I said, number of events would be satisfied. Uh, Number of trials would be the entire sample size. Uh, and then the continuous predictors are numericals, variety of drinks, and number of waiters. And then categorical is free refill. And then you can go to options to just check everything's good. Yeah, likelihood test is what you would want here. Uh, so hit OK, and then just hit OK and run the test. So here you can see the results. A few things that you want to check here in the results is these p-values of the coefficients. So the p-value here for variety of drinks is less than 0.05. Number of waiter is less than 0.05, and for free refill yes is greater than 0.05. So the null hypothesis in this case is that the variety of drinks does not affect the customer satisfaction. We have to reject that null hypothesis because the p-value is not greater than 0.05. Similarly, the null hypothesis here is that number of waiter does not affect the customer satisfaction. We reject that as well. So both of these factors affect the customer satisfaction significantly. However, in the case of free refill, yes, we have to accept the null hypothesis that it does not affect the customer satisfaction because the p-value is greater than 0.05. Another thing you want to check here is the goodness of fit test. Here, the null hypothesis is that the model fits the data properly. So in this case, since the p-value is above 0.05, you have to accept that hypothesis, that null hypothesis, that model does fit the data properly. And then you move on to the analysis of variance, ANOVA. The overall regression model has a p-value of less than 0.05. That tells you that the model, the null hypothesis in that case is that none of the factors affect the customer satisfaction. So you have to reject that and say at least one of the factors definitely affect the customer satisfaction. That is what you have to accept. And to individual factors, their ANOVA p-values are also less than 0.05, less than 0.05, and greater than 0.05 here. So which means that variety of drinks does not affect the customer satisfaction. That being the null hypothesis, you have to reject that. Number of waiter does not affect the guest satisfaction. You have to reject that as well. And free refill does not affect the customer satisfaction. You have to accept that uh, because the p-value is above 0.05. So that's overall the reading out the results of binary logistical regression with these three factors. But now that we know that one of these factors are is not significant uh, in the customer satisfaction, we can build a little slightly better model by actually not accounting for that factor. So that's what we're going to be doing now. We'll run this binary logistical regression again. However, the only difference we'll do this time is we will get rid of this categorical predictor, which is not significant for the customer satisfaction. Everything else remains the same, and then you hit OK. And what you'll see is basically the same kind of p-value verdict, which is less than 0.05. But one little slight difference you'll see is the goodness of it is slightly better in this model. Uh, P-values are also slightly less, smaller, or pretty much the same. But it's slightly a better model. We know that because it only considers these two factors and does not consider a factor that is not significant. So there we have generated a good binary logistical regression model. So we created our binary logistical regression model with three factors, and then we improved that model by removing one of the non-significant factor, and we created another binary logistical regression model. So then we move on to creating a mesh data because Now that we have created a model from the survey data that we had acquired, now we want to calculate the probabilities for different levels of these factors, influential factors. And for that, we will be using mesh data and select certain levels of drinks and certain levels of waiters and see what the probability comes out for each of these combinations. Now, since we want to create different levels of variety of drinks, I'm going to name this column as variety 2 and name this column as waiters 2. And and this one column I'm going to call it as probability satisfied for these factors. All right. To make mesh data, you go to calculate, go to mesh data, and here you store the value variety 2. The y would be variety waiter 2, and the values that we want for variety is from 3 to 6, 3, 4, 5, and 6. And so that's why we mentioned 3, 6 here, and number of position would be 4. And the levels we want for waiter is from 10 to 20, only 3 levels. So 10, 15, and 20. So that's the levels we want for each of these influential factors. And based on that, we'll be calculating our probability. So, so now the Minitab is going to make all the permutation combinations of these uh, 4 levels and these 3 levels together. And that's what you have here. As you see, 3 to 6 are the values that are repeated, and then for each of these values 10, 15, and 20. Now we have to calculate the probability. If you remember in the slides, we looked at the probability formula earlier in our define phase. So this is basically the formula that will give us the probability, where obviously b1, b2 is the coefficients that we found from our updated regression model, and then x1, x2, these are basically variety and waiter levels that we have in our mesh data. So basically this formula here, p events, probability event, that is the formula we need to calculate for these two data, and coefficients were obtained from our model right here. So to do that, we go to calculate, we go to calculator, and we put the formula here exactly as this formula, and you substitute basically uh, you multiply variety 2 with 0.409, you multiply 0.4 uh, 0.1410 with number of drinks, or sorry, number of waiters, or waiter 2, and then you divide the whole thing with 1 plus the same formula, and assign as a formula. The results are stored in probability satisfied column, and then hit OK. And there you have all the probabilities calculated for these different levels of drinks and different levels of waiters. Now, to see these probabilities better, we can visualize this using a graph. So for graph, you can go to scatter plot, you can do connect and groups, and here since we have 3 levels of waiter, we can put waiter 2 as categorical data 0 to 3, and then on the y-axis you have probability satisfied, on x-axis you have variety of drinks, and let's hit OK and see what comes up. So basically this is the plot right here. that shows clearly that for 20 number of waiters and highest variety of drinks, the probability of satisfaction is the highest, around 0.46. And then as you decrease the number of waiters to, let's say, 15 waiters, the probability of satisfaction decreases. And then if you decrease the variety of drinks, probability of satisfaction decreases even more. And similarly, for only 10 waiters and 6 drinks, probability of satisfaction is the best you can get with 10 waiters. And then it keeps decreasing based on reducing the number of variety of drinks. So that essentially is the analysis phase, where we created the binary logistical regression model with three factors. We found out that one of the factors are non-significant, so we updated our binary logistical regression model to only two factors. From that, we got the coefficients, and now we created different levels of the factors, influential factors, to calculate the probability for them using the coefficients that we previously found in the model. To that extent, we used mesh data, and we used that formula to convert factors and coefficients into probability. And then finally, we plotted these probability on a graph to visualize how the factors affect the probability. And that is the analyze phase. Next, we move on to improve and control phase, which is the last phases of the demake process. Here, after having completed the analysis, the manager basically recommends the owner that they should stop providing drink refills. They should increase the variety of drinks on the menu, and they should also increase the number of waiters working in the restaurant. Owner considers these recommendations and encourages the manager to continue collecting feedbacks from the customers in the future, so that quality control is improved and controlled. And that overall concludes chapter 5, binary logistical regression for measuring customer satisfaction.